So we're going to talk about hydrates. I can show you a hydrate. This is just little crystals. This is copper sulfate, pentahydrate. This is a common one you look at. Well, it's blue, it's nice, right? You can kind of imagine that it has water in it. Then we have calcium chloride dihydrate. This is the one I'm using today as an example. You can see the formula right on the bottle. Right? Calcium chloride dihydrate. And this one's white. So if you looked at these, this is dihydrate flakes, technical grade. If you looked inside here, and looked at these flakes, you'd be like, oh, that doesn't really look like water. But there's water in there, right? So that's, anyway, we have these hydrates. So calcium chloride dihydrate is the example that we're going to use today. Calcium chloride we name just as usual, and then however many waters there are, you're going to put a prefix in front of that. So if it was 1, it'd be monohydrate. If it was 5, it would be pentahydrate, and so on. I wrote here, I'm looking to calculate the mass of the anhydrous salt. So anhydrous is a word to write down and remember. Anhydrous means without water. So if we did not think about the water, we're just thinking about the mass of the calcium chloride. We'd say, okay, we've got 1 calcium atom, we've got 2 chlorine atoms. Calcium's 40, chlorine's 35.45. And we added up, the mass of the anhydrous salt is 110.98, which, if we didn't see that, we'd just be calling it some salt. That salt, you might want quotes around it or not. So sometimes you think of table salt, or you might think of some other salt. Just if we're looking at an ionic compound, we a lot of times these can be referred to as salts. So mass of water. Well, we have 2 water molecules. When you get the molar mass of a hydrate, I recommend leaving the water together and just thinking of it as 18.02. It's a small molecule, so 2 times 18.02 is 36.4. So we have the mass of the water, and we have the mass of the anhydrous salt. Molar mass of the hydrate is just going to be the salt plus the water combined. So we get a total mass of 147.02 grams per mole. All right, so that's fine. The questions that you're going to need to be able to answer, right? You kind of need to understand what it would look like in the lab if you're going to be heating this, right? If you're going to take this and you're going to heat it, and you're going to drive out the water. You can calculate how much water should leave. So one question we might ask is, how much water is in 10 grams of calcium chloride dihydrate? So if I took this out, if I took out the calcium chloride dihydrate and I weighed it, got 10 grams, and I started heating it until all the water comes out, and the way I would know that is that even when I keep heating it, the mass doesn't change. Okay, it's called constant mass. We'll get to that in a second. But how much water is in 10 grams of calcium chloride dihydrate? Now I just need a conversion factor that is going to get me from the thing that I'm starting with, which is the hydrate, and then I want to know water. So I need a fraction that is going to be true, and for every 147.02 grams of calcium chloride dihydrate, there are 36.04 grams of H2O. And just keep in mind, you're not writing the coefficient of 2 there, you're just writing 36.04 grams of H2O. Oh, we get out a calculator, right, at 10. All right, so 4 sig figs, because we started with 4 sig figs, so we're going to end with 4 sig figs. You should get 2.451 grams of water, and there's your answer. Just make sure whatever fraction you're writing, it's true that this mass of water, or whatever you're talking about, is true for every this mass of whatever substance. Next question, if you heated 3.12 grams of calcium chloride dihydrate to constant mass, so that's another term you might want to write down. Constant mass. So you're going to see this if you have a question where you are heating something and you're decomposing something, or in this case you're kind of just driving out the water. Heating it to constant mass means you heat it and you weigh it. And you heat it some more and you weigh it, and it's the same mass. That's constant mass. Okay, if you heat it to constant mass, what is your theoretical yield? So theoretical yield is what we expect when we do the math. Right? We're starting with 3.12 grams, so theoretically we should have some mass at the end. That's just with paper. You go in the lab and do it, you might measure a different number, but on paper is your theoretical yield. Okay? If we heat this to constant mass, that means all of this water is going to be gone, and the only thing that's left is this ionic compound, because ionic compounds have very high boiling, very high melting points, so you're not going to drive that off. The ions are going to stay where they are. But I need a conversion factor. I need grams of calcium chloride dihydrate to be in the denominator. And grams of calcium chloride anhydrous. Calcium chloride would be in the numerator. We got 1. So not only do we know the mass we'd expect, right, there's the constant mass, 2.56 grams. Should be 3 sig figs, because we started off with 3 sig figs here. We got 3 sig figs. We know the mass, but we also know the formula, right? It's the same formula, just without the water. So this is your anhydrous salt. There's your water. Those are hydrates.